snow buildup affect that?
Snow buildup, that's really funny. What happens, because the panels are off the ground a little bit, the snow gets pushed up a little bit into the wind. So the amount of space here, the dead air, is actually lighter than the amount of snow that would fill that area. And what happens, even though during the snowfall, the snow will fall and stick on the panel, the first day that the sun comes out, these panels, when a corner of it becomes visible, it will immediately heat up because the panel is dark. If you keep your car closed, even in the winter, with the windows, some days you get in and it's hot. Panels work the same way. There's air in there that heats up, and the panel itself is black. And so once it gets heated, that heat transfers to all the aluminum. It actually becomes one big giant heat sink, and so it just melts the snow right off. So no snowstorm will affect these panels for longer than a day. The day the snow is falling doesn't really matter because it's already going to be cloudy anyway, no sun. So you're going to have less power output. So in a twisted kind of way, the panels will actually lighten the snow load. You know, that instant, the day it's falling, it'll be a little heavier, but then it'll melt the snow faster than the regular roof will. So that's important too. That's the other reason why we wanted the higher angle. If they were flatter, it might take a little bit longer to get the snow melt, but the taller the angle, and that's what this picture is supposed to represent. Yeah, this is that's your December sun angle, and then this is your June, July angle of the sun. And so your panel, you know, obviously, if it's facing the sun in a perpendicular, is the best. And so in the summer, you want a flat panel. In the winter, you want an angled panel. And so we had to split the difference, and that's why we're going with 15 degrees. Now, those are our choices, kind of 0, 30, and 15. And it turns out that, you know, we only lose 1 or 2% of the power output by choosing 15 over 30. And you'd actually lose more by going to 0. And here's why. This is an interesting thing with that. 0 would be better because you get the summer sun. Panels are actually more efficient in the winter. And that's because it's colder outside. Just like a computer or other kinds of, like your car, you always try to keep the engine cool because it runs more efficiently. Same thing with the solar panels. So in the winter, solar panels are more efficient in the Northeast even than they are in the Southwest. So a lot of people like to make up things that solar doesn't work in the Northeast. It's not true. Solar panels actually overproduce in the winter on a clear day because it's so cold outside. Our panels are rated at 210 watts. On a clear summer day, we'll get 240. Or a clear winter day, I'm sorry. And then on the summer, because even in New England it's hot, the panels, even though they'll have more sun, they'll be hot, and so it'll go back down to like 210 or 200 watts per panel. And that's kind of the interesting stuff we'd like to monitor, because there's a lot of people saying that, but we haven't seen any kind of study or research, and that would be the kind of cool stuff when we monitor this equipment that we can get from it.
How big are these panels?
3 by 5, 3 feet by 5 feet.
And they only generate 200 watts?
Yep. So there's going to be 400 of them.
Just seems like so much for just 2 light bulbs.
Yeah, well, it's in terms of size.
Yeah.
Yeah, it is. I mean, it's a lot, but the only benefit is that it lasts for 40 years. Now, if I could put 40 years of coal on the ground in front of you and say this is how much coal you'd have to burn to power those same 2 light bulbs, you take the panel, because the coal would be like this.
How much is each panel, like price-wise?
It depends. If you called up a place and bought it, it would be a different price than for us. The range of prices is anywhere from $200 to $600 per panel.
And do you get a discount for buying in bulk?
You do. And here's how a lot of people talk about when they buy solar, they talk about the price per watt. So dollars per watt. And so a good size house system that would generate all of the electricity in a house over the course of a year would be 3,000 watts. Let's just pick that. And a few years back, the magic number was always $10 a watt. And so you know that a 3,000 watt house system would cost $30,000. Today, the federal government gives you a 30%, we'll just call it a discount. It's either a tax credit or some other way. 30% off from the federal government. And let's just assume you're in a state like Massachusetts. They'll give you another 20%. And now all of a sudden you know that you're already at 50%. So you're at $5 a watt in the old price. The current price is about $7, $7.50, maybe $8 you can get. And if you buy them in bulk, like the size we're buying, we're getting it down to closer to $5 to start. So you take 5, take 30% off that, and then you see the pricing start coming together. And there's always incidental expenses associated with that, but you will see, you can go online and you can see, there's a lot of these stores that sell solar panels by the pallet, and you can see how the price drops. So if you were going online and buying this kind of system, you might pay $7. If you can go and buy 26 panels at a time in one pallet and get it shipped, you might be down at $4.60 a watt. So, but you have to buy all the other stuff too. You have to buy inverters, racks, and then you have to have a person install it. So that's been one of the traditional challenges with solar. It's so much up front. Even though it saves you money for a long time, it costs too much up front for a lot of people, particularly a homeowner. It's hard to justify spending $30,000.
It's a car. It's a car.
Yeah, it is. And that's where we came in on this project. It's hard to come into the school district and say, you'll save a lot of money, but you got to spend $800,000 up front. And we came up with the idea, well, we'll go out and finance that, and we'll take out the upfront cost, and you just pay it over time from savings. It's called a shared savings contract or an approach. And I'd be happy to talk about that going at some point in the future, because I don't know how interested you are in the financial aspects, but you can see how this thing kind of works. There are companies, Google has a lot of solar. Staples, they're putting solar on all of their stores. And there's a company doing that called SunEdison, and they're using this model. SunEdison is going to buy the system, put it up, and Staples is going to pay them over time through the cost of the electricity. Okay. I didn't talk to you before, but they told me like 40 minutes.
Just one question. This is going to be putting power out onto the grid if it's not being used, just like the microturbine?
It would, but that high school uses so much power that we would have to double or triple the size to get to the point where we were actually overproducing.
So they're going to be using grid at night, for example?
Yes.
And so how about the microturbine? That puts power out on the grid if it's not being utilized?
Yeah, it might. We think that we're pretty safe, because we think the base load in these two buildings is about 80 to 85 kilowatts, and that's at night too. And so even if it's running at night, it's going to be producing 65.
But I mean, if it does though, do you get like do they get money for it?
Yes, there are two different ways to do that, and one of them, if you have renewable energy like solar, they just credit you the full amount, but because this is natural gas and there's a lot of subtleties to all this stuff, they'll only give you the wholesale price rather than the retail price. So let me take some input from you guys before I have to leave here. The microturbine is coming in 3 weeks or so, and my idea was that you guys probably wanted to see that thing. So I was going to see if we could get it, when it gets here, get you down there, pull the sides off, look at it, listen to the guys from the company talk about what it does, and you can actually see it. And then maybe during the installation a couple of times go see it. And then in the end of November, the beginning of December, we're going to have a build day over at the high school, and we'll actually put the racks and the solar panels together on the ground, and then we're going to lift them pre-manufactured and drop them onto the roof. So all that stuff is coming up over the next 4 weeks. Anybody have any input on what you want to see? If you have no input, I will just assume.
Well, I've given Margaret a list of several students here that were interested in going over.
Okay.
The day you do the vote over there. She said one day, I think it was the week of the 1st of December.
Right. The panels actually are starting to get delivered next week, and then we'll slowly take shipments over the course of the next 2 weeks, and we'll have that date solidly pegged as once everything is there.
Yeah, she needed a list of names because we have to check that with her.
Great. Okay.
But there will be several students here this class involved.
Good. Okay. So that's what we're doing. That's an introduction. There's going to be